Bismillahirrahmanirrahim. So students, today I will be trying to explain a few topics that I think are a little bit confusing and causing trouble to many of the students. So this topic is related to three-phase AC systems, how we find out the critical values, what is the meaning of positive sequence, negative sequence, and few of the things like this. So I will try to make the video short. So first of all, the key and important terminologies that everyone should know. There are two arrangements, basically known as delta and Y, and this is a Y configuration, and similarly load can be connected also in Y configuration, and we can say this is A, B and C. The important terminologies that we should know, one thing is known as phase voltage, that is the voltage of one source. It is VAN. Then we have VBN and we have VCN. If we draw the phases, now this is the system in actuality. Now this can be a positive sequence source or a negative sequence source. So for being a positive sequence source, that we say positive sequence, it means that it is ABC sequence. And what is meant by ABC is that if the reference vector, that is VAN, we assume this is VAN, lies at this axis, and we rotate this x, VAN, or any vector, the A part, if we rotate it in anti-clockwise and it passes through a point, I call it P, then after the passing of this vector, the next vector that should cross this point P should be B. And when we look at negative sequence, in negative sequence case, if this is the vector VAN, this is a point P, and if I rotate this vector, then the next vector that should cross this point is C. So I write it like ACB. So this is the basic and fundamental difference between negative sequence and positive sequence. So let's look at the positive sequence. So we have VAN, then the next vector. Now the phase difference between all these vectors will always be 120 degrees apart. So VBN will be from VAN minus 120 degrees, and then we have VCN, and this will be again either minus 240 or plus 120 degrees from VAN. So these are the phase voltages that I have written in the vector form. And similarly, in case of negative sequence, here we will have VCN and here we will have VBN. So this is regarding the phase voltages. Now there is another important terminology that we must understand. It is related to the lines. So lines are these quantities that come out of from the one terminal of a phase, and the voltage between two lines is known as line voltage. For here, this line is line A, this is line B. The voltage between these two lines is VAB, and this is called line voltage. Similarly, there will be a voltage between line B and line C. It is called VBC. And there will be a voltage between line C and A. So why have I not said voltage between line A and C, but I have said CA. This again goes to the positive and negative sequence order. So we have a positive sequence A, B, C. So we will always measure the voltages or make the phasor like VAB. Then there will be VBC. And then, as I have told you, the vector rotates. It will be VCA. So in the positive sequence, we have the three line voltages as VAB, VBC and VCA. Now again, sometimes students get this confusion. So we have VAN, VBN and VCN. Now the formula for our line voltages was VAB equals to under root 3 VAN angle plus 30 degrees. So in this case, this VAB can be calculated by multiplying VAN by under root 3 and adding angle of 30 degrees to the angle of VAN. So where should I draw VBN? So basically from VAN the angle is 30 degrees. So this is basically VAB. This angle is of plus 30 degrees. If VAN is 0 degrees, this will be 30 degrees. Now where should be, now the rest of the vectors, it is a positive sequence, and if I start rotating, so after VAB, the vector that will come will be VBC, and from here the vector that will come will be VCA. So this is how phase and line voltages can be drawn in positive sequence, and the same will be happening for the negative sequence. If you want to see, then here the line voltages will be VAC, VCB and VBA. VAC, CB and BA. This will be the vector. And where will we draw? This is VAN, VCN, VBN. VAC will be plus 30 degrees, and then VCB will be here and VBA will be here. So this is actually few critical values related to a Y connected, but the concept of the terminologies remain the same. Now let's look at our delta load or delta source. So what we have in a delta source is, for example, we have our sources here A, B and C, or we can have our load also connected like this, A and this is A, this is B, this is C. So in this scenario, if you can see here, this is the voltage, that is the phase voltage, that is the source voltage, or we call it phase voltage, and in this case it is VAB. There is no VAN in this case. There is no concept of neutral here. So VBC is this one and VCA is this one. When we look at the load side. This is the voltage at VAB, and this is VBC, and this is VCA. The important thing to note in this case is if we consider this is line A, this is line B, and this is line C, we can see that both the line current, both the voltage between both the lines VAB is also same as the phase voltage. Similarly, between VBC and VCA. So the voltages of the phase voltage and the line voltage are same for delta load. V phase equals to V line, both for the delta source, and we can see both for the load also. And this was regarding the voltage. Now there is an important another quantity that we must know and remember, and that is our current. So there is one current for a while source. This is I phase from the source, and when we talk about the load, this current will be flowing into the load. And this current, when flows through the line, this is called line current. It's called line current. Now in case of Y load, we see that there is one phase of the load is connected with one portion of the line. So whatever the current that is coming from the line will go into the phase. Similarly here and here. So if you look at this, that this current, same current goes to this line. So line current and phase current are equal in case of Y load. So if only we have Y load, the line current and phase currents are equal. But when we look at our delta load, where the line voltage and phase voltage was same, but when we talk about line currents, when you talk about the line current IA will not be equals to the phase current. So how will be the phase current? This is IAB, this is IBC, and this is ICA. They are not equal. But in this case, in Y load, they were equal. So how can we calculate this line current? In case of delta load, the line current can be calculated IA equals to under root 3 IAB, and there will be an angle shift of minus 30 degrees. There will be an angle shift of minus 30 degrees. So this is actually a revision about the basic concepts and positive sequence and negative sequence. And in the next few slides, I will try to solve few examples, and I hope this topic will become more clear.